Okay, so we've been doing review of yesterday's lesson because not many people did their homework in this hour. So I want to make sure. So I've gone through the first problem for our first problem set, and then the other problem for the next problem set is this one here. And it was about recursive formulas. And so for a recursive formula, recursive definition, you have to have two things. You have to have the first element. You have to have your a sub 1. And here, when you look up, what was our first element? How many items was it? Oh, 1. So a sub 1 was equal to 1. And then we've got to write that recursive formula. So I was just sitting here doing the algebra. We knew that the current item minus the previous, let me use correct terminology, the current term in the series minus the previous term, which we're going to say the n minus 1, is just equal to n. And that held true for all the blocks in this picture. All right. So this is getting picky. This thing's going to freak out on me again. But I just tried to clean it up so I can show one last time, then we're going to move on. All right. So we know if this is a sub 1, a 2, a sub 3, a sub 4, a sub 5, and a sub 6. We know that when we subtract with recursion, you compare the current to the previous. So you have to start with the second element, right? And that's really why we have to know the first element. Without a first element, we could go nowhere. So you have to define that first element, which was defined to be 1. So we know a sub 1 is equal to 1. Now let's look what happens when we do the current element, I'm just going to call a sub n, minus the previous element, which is the a sub n minus 1. We found that when you subtract them, the 3 minus 1 was equal to 2. Well, that's just our current n, right? And we did that for every problem here. So a sub 3, so now our n is 3, minus a sub 3 minus 1, which is 2. So 6 minus 3 is 3. So it turned out again to be our n value. So it's still holding true. And when you test each one of these, it still holds true. Subtract them, and you're going to find that a sub n minus a sub n minus 1 is equal to n. So when we write that, we still have to write the formula as a sub n equals. So that means we've got to put this over here. So it was subtracted, so we need to add to get rid of it. And we have to do it to both sides, right? So then it goes away here, and we have a sub n equals n plus a sub n minus 1. Now we've got our full recursive definition. So our first term is a sub 1 equal 1, and then our formula. Because remember, we have to have both of those for the definition. So there it is. And how do you know you're in a recursive definition? Well, when you see an n here and you see an n minus 1, part of that, that's a pretty good hint that you're on recursion because you're comparing the current element to the previous element. Okay, but that's just one of the things. So the rest of this assignment was just working 7, 8, 9, 10, and 11. All right, and we're not going to do 12. So again, did we work 7 together yesterday? Okay. So how many of you are not finished with this assignment? Be truthful. About half. So I want you guys to take this home over the weekend and finish it. Now on top of that, you've got the current one. Okay? And we'll turn everything in on Monday. Remember, Monday's Khan Academy. And I will not be here for the afternoon session. I've got appointments I have to attend. So you'll either be going to a different class, which just know to do your Khan Academy, or I guess I won't be here for you to turn it in. So we'll turn it in first thing Tuesday. All right? But don't sit on it all weekend. I would go home and do it tonight. So it will be done, and I would take a peek at it every day so you don't forget about it, because this chapter is gonna go fast and it gets harder very quickly. So don't get lost, because we can't go back like I'm doing now. All right, now to move on to today's stuff. I ask you to copy in your math journal. An arithmetic sequence with a starting value a and a common difference d is a sequence of the form a, comma, a plus d, comma, because d is the difference, right? So if we're trying to just figure out, if I've got a starting value of a, let's just say it's 3, and then everything has a common difference, let's say of 2, let's say our d is equal to 2. So we're going to start with this arithmetic sequence. A sequence is just to order a string of numbers, right? So a plus d, what was our difference? 2, so it's going to be 3 plus 2, 5. And now a plus 2 times d, so 2 times 2 is 4. So it's going to be 3 plus 4, it's going to be 7. And the next one's going to be 9. Okay, so do you see as we move on, you're continuing to add 2. So even if I wanted to know, okay, I've got the first 4 terms in this right here in the sequence. Well, what is the 100th term? Well, we know it's going to be wherever we left off, right? And how far do we have to go? What term are we going to? We just have to add that many differences to it. So that's where this 3 times d, 2 times d. So if you're going 100 down the line, would it be 100 times d? Maybe and maybe not. So that's what this lesson's about, okay? So let's look at it. So that was for an arithmetic sequence. All right. Now, what about a recursive definition for this sequence? And we know it has 2 parts, and I just talked about it, the initial condition and then the recursive formula. So here's the recursive formula for this. And notice that they qualify this, the n must be greater than 1. Well, when you're talking about the number of elements, a sub n, you're not going to have 0 elements. If we're talking about something, it had an element, right? We're not going to do math with something that had nothing to it. So you'll never have an a sub 0. Let's say nothing exists here. You can't do math with nothing. Your list is going to have at least 1 value, right? So it's not going to have negative values, right? It's all going to be positive. So that's why they say the n must be greater than 1, because we can't have negative elements, something that doesn't exist or hadn't been invented yet, I don't know. And we don't have 0 elements. So everything must be, n must be greater than 1. Okay, so our first element, all right, let me back up. Let me get through this. Okay, so let's just look at the definition, and then I'll go into the lesson here in a second. So a sub n equals a sub n minus 1. N greater than 1. Why do you think they said n must be greater than 1? Because if I put a 1 there for n in the recursion, what do I have? I have a 0 element, a 0 term, which doesn't exist. And remember, with recursion, you define your first element. You state what it is. It's always given to you. And then you're going to look at the second element and compare to the previous. That's recursion, looking at your current term compared to the previous. So you must have an initial term or nothing can be done. Right? So when you start your math in recursion, you're always starting with the second element compared to the previous. All right? So that's all that n is greater than 1. Okay, now an explicit definition. So we've talked about 2 things here, a recursive definition, an explicit definition for the sequence. And we're talking about what kind of sequence? An arithmetic sequence. A starting value of a and a common difference. Okay? So now we've got the recursive definition for this. Now we're going to go to the explicit definition. For the explicit definition, it's given in one single formula, so you don't have to remember to define the first term. It's just going to be this, a sub n equals a plus n minus 1 times d. For n greater than or equal to 1. Greater than or equal to 1. So it could be 1. What would happen if it's 1? So if I had the first element, well, 1 minus 1 is 0, but I still have an a value, right? I still have an a value. So, and we could have 0 times d. We could have nothing there, right? It's possible. So these are the things that we're going to run into in this lesson. Okay. So I had you copy this so you've got these at home. So the two things you'll focus on in this lesson is the recursive definition and an explicit definition. Okay. That was from my programming class last year. Everybody programmed their own voice to go yum, and they had this little monster going along chomping up ants, and he would go yum 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 in their own voice. So sorry, I hijacked this lesson and put that in there. All right, sometimes it's helpful to represent a situation with a sequence of numbers, right? So that's what we do in algebra. We're always representing some kind of real world problem. That's what we're getting to in every lesson, hopefully. There are different types of numerical sequences, different types. So what our essential understanding is, in an arithmetic sequence, the difference between any two consecutive terms is always the same number. That was that D number, remember? The difference is the same between them all. So if I had, let's say, 3, 6, 9, 12, what's my difference between all these numbers? 3, and it's the same between all of them, right? The difference, 6 minus 3 is 3, 9 minus 6 is 3, 12 minus 9 is 3. So I've got the same difference. So we could say that our D is equal to 3. Okay? Does everybody see that? That's all this is talking about. The same difference. All right? So in an arithmetic sequence, the difference between any two consecutive terms is always the same number. You can build an arithmetic sequence by adding the same number to each item. Okay, so that's the first thing. Quite easy, right? And then an arithmetic sequence is a sequence where the difference between consecutive terms is constant. This difference is called the common difference. So when I did the 3, 6, 9, 12, it's the same difference. That 3 remains constant. Okay, and my common difference here is 3. Everybody see that? That's what all this first problem set's about. So let's look at this first problem. Oh goodness, it's the same thing. Find the difference between all the consecutive terms. So what's our difference here? I've been doing it over and over. What is it? 3. So when you subtract these, so what's the difference between 6 and 3? 3. 9 and 6, 3. 12 and 9 is 3. 15 and 12 is 3. Are all of these differences the same? Then that's a common difference of 3. Let me hear everybody. So we can say because they have a common difference, this is an arithmetic sequence. So yes, it is. Because it has a common difference of 3. Let's look at the next one. 1, 4, 9, 16, 25. 1, 4, 9, 16, 25. Write that on your whiteboards real quick and tell me what's the difference between all of these. So 4 minus, oh my goodness, I'm losing my voice. 4 minus 1 is 3. 9 minus 4 is 5. Keep going. 16 minus 9 is? Now, I want you to tell me at the bottom, does this have a common difference? Yes or no? So do a big yes or a big no at the bottom of your page. And hold your board up for me to see. Good. Good. Yes, yes. Oh, I should say good. Good. Look one more time. Look one more time. What we're looking for is, are all of these differences the same? When you subtract every adjacent number from its previous number, are all of those differences the same? Are they the same? Check again.
These aren't, but once you...
No, you don't go 2 levels, you go 1 level.
Alright, then I'll change it back to...
Good. Good. Good.
But they all have 2 in between
Good.
them, so...
Okay. Think silently. Good. 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 Okay, good. So I've seen almost everybody. So here's what we would have done. Don't erase yet. When we do whiteboards, never erase till we are completely on to the next problem. Because what I want you to do is look at your work. Make sure that your work compares with what I do up here. If you could still have a right answer and still be doing things wrong. It could have been a fluke that you just picked it right. So make sure you're fully understanding by comparing your whiteboard, and we will use whiteboards a lot from now on. Okay? 16 minus 9 is what? 7. And 25 minus 16? 9. So are all of these differences the same number? No, they are not. So this is not an arithmetic sequence. Now if you go another level, yeah, all of those were, but we're not doing that. Okay, that's for another day. Today we're looking at the first level difference. Okay? Any questions? All right, so let's look at the next bunch. Oh, actually, we're not working anymore. Look at your homework on 9-2. And look at 9-1 on number 1. It's, 9-2. Look at problem 1 on 9-2. It gives you, on problem 1, the numbers 1, 4, 7, 10. And it starts doing the 4 minus 1 is 3. 7 minus 4 is 3. 10 minus 7 is 3. So it gives you all those. It tells you, because these are all the same, this sequence is arithmetic. So yes, it is. But what is the common difference? What is the common difference? Everyone speak up. What is it? 3. So it's all those same numbers. That's your common difference. So write in 3 in that box. It says the common difference is 3. Any questions on that? Look at number 2. You've got 6, 10, 14, 18, 22. Work that real quick. So is it an arithmetic sequence? Yes or no? Yes, because what's its common difference?
4.
Okay. Now, tonight you will go home and work 3, 4, 5, and 6. Okay? And 7. So you're working 1 through 7 for this first problem, and now we're going to move on. Okay? So please, I had a couple people earlier in the day that continued to try to finish their work while I'm teaching the next problem. Then they had questions about how do you work that problem that I just finished, because they weren't paying attention. Please, when I do a stopping point, just know that's what you finish at home, and let's move forward, okay? Because I want to get you guys through this. This is just what you copied at the beginning of class, so I'm not going to go over it again. So just know we're talking about recursive definitions and explicit definitions. All right, so problem 2, analyzing an arithmetic sequence. What is the 100th term of an arithmetic sequence that begins with 6, 11, and so on? Okay, the ellipsis, the 3 dots, means it goes on and on and on in the same pattern. Okay, so what is the 100th term? So we have to figure out, how do we determine? Well, we have the first term of the sequence, we have 6. So how did we get to from 6 to 11? Well, let's just do the math, subtract them. 11 minus 6 is what? 5. So you think to go to the next term in this sequence, we're going to take 11 and add 5. And then to go to the next term after that, we should add 5 more. Right? Should it be that? So we know that the common difference between all of these is 5. And they want to know what is the 100th term. So since we've been given even just the first two, we don't have to worry about any others. As long as we have the first two and we're told it is an arithmetic sequence, we just have to get the difference and then plug it in the formula. So that is what's so easy about this. So you go back and get that arithmetic sequence formula, right? So are we going to do explicit or recursive? Well, it would be the explicit, right? Because we're not comparing against the previous. We subtracted them to get a difference. So that's your explicit formula. So we know that we're going to use a sub n, and that's what I had you copy in your notes, equals a plus n minus 1 times d. So now we're just going to plug in what term did they want to ask us for? What is the 100th term? So we want to know a sub 100 is equal to. And what is our first term? 6. So that becomes your a. So the a sub n, a is your first term of 6, and n is what you want to know. What term do you want to know? 100. So we have a of 100 is equal to a, which is our 6, plus 100 minus 1, because it's n minus 1, times our difference, which was 5. So our 100th value becomes 6 plus 5 times 99, which is 501. So that's what it would be for the 100th term. Okay. Now, there's something else. 8, 9, and 10 are like that. But let me show you problem B. And you will work 8, 9, and 10 this weekend. And hopefully 11, 12, and 13. So let's look at the B. And this goes with 11, 12, 13. What are the second and third terms of the arithmetic sequence? And they give us 100, blank, blank, 82. Well, we know it's a constant difference, right? So we've got a term plus two differences to get to 82. So let's just plug it into a formula, right? So we can say that 82 is equal to 100 plus 2 of the differences. Excuse me, 3 of the differences, because look, there's 2 boxes. So we need to get to that difference, and that difference. So there are 3 differences in here. Okay, so 82 is equal to 100 plus 3 of the differences. So now, when you start just using simple algebra, you're going to subtract 100 from each side. You get negative 18 equals 3 differences. Then divide each side by 3, and you get the differences, negative 6. So let's look. If we start at 100 and we go minus 6, that's going to be 94. 94 minus 6 is 88. 88 minus 6 is 82, so it checks out. Our difference is negative 6. Okay, so just remember, just use simple math. There's actually neither formula you're plugging in, you're just doing your simple algebra. Because you know 82 must be equal to 100 plus 3 of those differences. Okay? And that will get you through problem 13. The last thing that I want to show you is the easiest out of all of them. It's called the arithmetic mean. So when I talk about the arithmetic mean, the average of 2 numbers, if I give you 2 numbers and they're missing the number in between, like 15 blank 59, well, what are you going to do? You need that middle term. So it's got to be the average of those 2, right? So you're going to do 15 plus 59 divided by 2, and you get 37, and that's how it rolls. So when you're missing just one term in the middle, just average them. 15 plus 59 divided by 2. Okay? And that's everything, guys. So what I want you to work is through number 19 over the weekend, and that will be it, and that gets us through the lesson. Okay? You're awful quiet. Any questions on any of this? I know I went really fast, but we did half and half. We actually did basically 2 lessons in one day, and then work some. So that was fast and furious, but we're getting there. All right, so again, I won't be here on Monday, and you will either, I don't have a sub yet, no one's picked it up, so you'll either go to another class, but regardless of whatever you do, every classroom has Chromebooks. Get on the Chromebook and do your Khan Academy, okay? And turn both of these assignments in on Tuesday, and then we'll move on to 9-3, okay? Thank you, and this concludes our lesson.